Hello students, this class we will discuss the uh, week number 10 problem number 1. So draw the isometric projection. Draw the isometric projection of hexagonal pyramid of sides base is 30 mm, height is 75 mm, and when it is resting on HP such that the edge of base parallel to PP, so we can able to simply make the simple position, but here we just going to make the isometric projection. So there is some difference. The isometric view, that the three-dimensional view that you are normally seeing. So for example, one rectangular prism you are normally seeing for all the direction. This is one direction you are seeing, another direction you are seeing, another direction you are seeing. It's considered as a normally it is considered as isometric view. But isometric projection, the same view you cannot able to project. So what happened when you want to see all the sides? See, for example, you can see the front view, you can see the top view, you can see the front view, you can see the top view, side view, you can project. It's a orthogonal. Okay, isometric is different. So here you see all with this time I need to see all the sides, so I will keep like this. So this is a isometric angle that I am keeping. I will explain later on. So this isometric angle, this projection, this view projection I need to make. Okay, for that what you can do, what is happening actually, this length is reduced, this length is reduced, this length is reduced, this height is not reduced. Okay, axis height is not reduced, this sides and base everything is got reduced. That is known as a isometric length. So the isometric projection, for isometric projection we supposed to multiply, we supposed to consider only 82% of the actual length. It's a very important point, actual length. The isometric projection is nothing but x, y, z. This is known as isometric axis, 120 degree all. This is known as a isometric axis. I will explain in theory. Just go through the theory. So I'm just going to project this hexagonal pyramid with this configuration. Okay, so the first one is nothing but the simple position, as we know, to draw for the pyramid. Okay, so the pyramid, they said its base sides of 30. So sides is 30, but it's parallel to VP. This is VP, HP. This is parallel to VP, hence I could start like this, the hexagon. We know only the exterior angle method. Okay, so the hexagon is supposed to be, so here the angular measurement that we need to make. So hexagon 6 divided by 360 is 60 degree. From here 60, don't have space. From here 60. I'm just making two lines with respect to this. Okay, so it is a 30 mm length. Just measuring 30 mm. And I am completing this hexagonal edges. Okay, once the hexagon is over, some mistake. So once the hexagon is over, we can measure all the required things. Okay, so erect a vertical line. So you will identify the axis. Anyway, it will occur in this region. This is 15. So axis must be here. The height of the hexagon is 75. I don't know space. Up to here. So since it is a pyramid, okay. Okay, fine. So we can give the name that as we required A, B, C, D, E, F and O. So O dash, A dash, B dash, F dash, C dash, E dash, D dash, as it is. So here with that we cannot able to project the hexagon. So for that there is two methods is available to develop the isometric projection. One is a box method, second one is a axis method. So we just going to see the axis method here for this kind of pyramid. When they are asked in section, we can go through the box method, both are simple. So for that, here the axis method, whatever it may be, we supposed to extend the line. We supposed to extend the lines of base to get the reference. Just extending the line, there is a reason for extending this. So I completed the hexagon in box. I just completed the hexagon in box. Let us name that is P, Q, let it be in a small letter. P, Q, R, S. These edges are very important to draw the hexagon in isometric plane. So now we need to draw the isometric plane. As already I started here, the axis of isometric, when you are cutting like this, when you are looking these two axes, let it be X and Y, we could able to fix that one. That means when you are cutting here, this is 90, remaining is 30 degree. This is 30 degree. Just to swap the same diagram, I am just going to use one horizontal line as a reference line, and both side there is a 30 degree angular line. So both side there is a 30 degree angular line. So first let me fix one point. Oh. This is 30. Okay, simply I draw. So let us fix this point P somewhere here. let it be P. This point P I transferred here. Okay, after that, the same direction, I'm just going to draw another 30 degree angular line. There is a reason. I'll explain. Once I complete, I'll explain. Okay. In another direction, I'm dropping the same 30 degree angular line. This same distance, P to Q, P to R, P to S, that you just measure and foreshorten the distance. Foreshorten the distance. That means I am reducing the distance. For example, P to Q I am measuring. P to Q I am measuring. I don't know the distance of P to Q. I am just measuring here. That comes around 6.1. Okay. So let me write here PQ, that is equal to QR, that is equal to RS, that is equal to SP, that is equal to 6.2, obviously 0.82 into 6.2, it's a isometric length, so 0.82 into 6.1 is came, it's a 6.2 almost, so it is 5.084. so let us say 5.1 mm is a distance. So this is a foreshortened length, FSL I am measuring. Foreshortened length. This only I am just going to use. So 5.1 I will measure here. There will not be any change in the angle. There will be a changes in only the distance. So 5.1. I just erase many things are there. 5.1 in this direction, 5.1 in this direction. Again, I need to complete the same this square. Okay, so this is we just made as a box. Okay, so it is completed. So this is P. Let us fix this one P. This is S. This is Q. And this one is R. So we drawn this outline of the pentagon. This is 30 degree. This is 30 degree. So angle will never change. Angle will not foreshorten. Okay. Then now, once you complete here, these are all you just mark in the capital letter for a difference. This is the final answer, right? So I just make this is P, Q, R, S as it is. Now you see, we can measure P to B distance. So we can measure P to B distance. We can foreshorten here. Similarly, whatever the all diagram that we can able to measure, also we can able to identify the center O. So all are foreshortened length. It's not a original length. For that, you need to measure and you need to transfer. So P to B is for example, P to B, let us measure and transfer. 1.6 is coming, 1.6 into 0.82. Okay, so 1.3. So I just measure here 1.3 and I am transferring here. So this point is known as a B. So I could say in a capital letter, so let me erase this 30 degree. This is B. Similarly, but P to Q is different. The length is different, that we need to measure and check what is the measurement. 2.8 is almost coming. So 2.8 into 0.82 will give 2.3. So transfer 2.3 here. Similarly, all the points. So this point is, we can name, that is A. Similarly, remaining points from S also, this distance will be same, and this same distance will be P. B will be as an F. Similarly, another point. So this we can, so 2 points is sufficient, I think. From P to B is equal to Q to C. Okay, we can understand from this drawing, Q to C. Similarly, R to E. Similarly, S to F. Okay, now A to P. Similarly, Q to D. Okay, this is can be D. So let us name, this is P, C, E, F, A. So you can connect. It will look like a hexagon in the isometric projection. Okay, so all are foreshortened length, very important. This is you make in a bold line. Okay, it's a foreshortened hexagonal pyramid. So we need to identify the access point O. How will you identify? We can connect these points and we can connect parallel to this line, the center of this line. This parallelly seek and you can get a point if it is a center. Yes, students. Yeah, I think I looked. This one we supposed to mark A, B, C, D, E, F as from the reference of P, Q, R, S only. Okay, only. It's very important point. I just marked the access point. So now we know the height from the vertical plane. All the height we know, but we don't know that much. We need only the height is from base to top, that is 75 mm as specified in this problem. So 75 multiplying by 0.82, that's it, is 61.5 as a foreshortened length. 51.5. Let me erect a vertical line. Erect a vertical line for axis. 61.5, that is 6.5. This is 6.5. I think 61.5 multiplying 6.5, that means 6.1. 61.5 mm. This is 61 and 5 is here. 61 point, that is between 61 to 62. So it is 60 here. So erect that directly, the vertical axis will not change in the isometric view. So this is O. This is, let it be O, R, O dash, whatever it may be, which we have named previously. Let it be the top apex point. Connect all. Where is my 2H pencil? Okay, so connect all from O to ABCDE. Okay, from O to ABCDE as it is, as such. So the pyramid will look slightly different. It is not an issue, but that is a isometric projection. That is a exact isometric projection. Use of this see behind there is something. I think that E is behind and D is behind. Either you can show in the dotted line too. Okay, so this is a final position, isometric projection. ISO. So let us recall everything. I just initially drawn the simple position. After that I make one box PQRS. So isometric projection means it's nothing but it's a foreshortened length. When you are looking any object, it must be foreshortened. See, it's a foreshortened. When you are keeping like this only, you could able to see side view, front view and top view together. So this is the position. The position is nothing but isometric axis. The isometric axis is nothing but 120 to all. See, x, y, z. It's all 120 degree. So when you are keeping it in a flat terrain, this side and this side, if you are keeping it 30 degree is remaining in xy with reference of xy. Okay, hence I fixed one point in xy, that is P, this point. So I just transfer all the measurements. I just transfer from here to here as a foreshortened length, because it is we kept in the axis. When you are keeping in these axis, 30 degree axis, there will be a ratio only 82% of the original length. So 82 into original length will consider as a foreshortened length we supposed to draw in this manner. This is the isometric projection of hexagonal prism. Thanks.